So, I am going to take Kuan's suggestion, and I'm going to consider this question. And if you're wondering, yes, you can do this, like this setting out. You can do it in the exam. It's fine. Because as you'll see, I'm going to solve this and use that to solve my other question. Okay? Alright, now, what would this mean? What would this mean? Think back to my equation before, right? About what exponentials are and what that equation actually signifies. Okay? What have I got here? I suppose I've got it backwards. Okay? I've got something that's growing at a certain rate. Then I have a time, and then I have a final destination. Okay? So does this make sense? I've got something that starts off at a certain size, and then when you look at the rate, right, it's getting smaller. Okay? That's why I'm going to get from 4 and 5 to 16 and 25 to 64 and 125 and so on. And it's getting smaller and smaller and smaller. So I want to know, this is the point of my sub-question, right? I want to know how long. Now, can you see why this is a long question? It's a how long question. How long will it take me to get to this? Right, this is the final amount that I'm interested in. Okay? Sorry, yeah, not a 0. Okay? Alright, now because it's in the index, right? Because it's a question of time, or how many lots, if you like, which is, again, the question of time. That's why I rewrite it as a log equation. Okay? So how do I do that? Let's say n is equal to, what do I write? Log base 4 and 5. So again, base becomes the base, okay? And then here's our 0.01. Okay, so you can see I've rewritten it in a more meaningful way. This is my rate, this is my final amount, this is the time it's going to take me. Okay, now, you can rewrite this, by the way. Do you know how to prove the change of base rate? Do you know how to prove it?
I did it once. Don't you use just...
Do you remember how to prove it? Do you want me to prove it for you?
Yeah.
So now that I've established this, let's come back and solve the question, shall we? I generally pick base E, okay? For one reason.
It's easy to write.
I have to write one less letter, and it's equivalent. It's actually equivalent. And in fact, like we just gotten a bit of a fuss over this on one of the Year 12 exams. This is unambiguous, right? When you see log and there's no base provided, it could be base 10 if you're on a calculator. It's a bit dumb. No one else ever uses it, but it's ambiguous when you don't have the base written. So that's unambiguous. So someone's calculator. What decimal value do we actually get?
21.6.
All right, yeah, I forgot how to round it up. Okay. Okay. Now, yeah.
Like when we use the change of base, it doesn't matter what base we use, so we don't have to write any of the actual.
Correct. Yeah. That's exactly right. Okay. So, being that we could choose any base we like, whichever one will get us to this point anyway. Now, what was the point? What did doing this? What did it solve? Okay. Think back. This is why I spent all that time trying to explain, what all of these bits signify. Okay. It means that after time, 20.63, blah, 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 okay? Time periods, okay? That's my time unit, okay? After that amount of time, that's when I get to exactly 0.01. That's when I arrive, okay? I started at something big, and it's getting smaller and smaller and smaller, and after I get this many times smaller, that's when I get there, okay? Now look at the question, what we actually want to solve. I want this thing, which is getting smaller and smaller and smaller, I want it to be smaller than that, right? I don't want to get there, I need to go a bit past it, okay? Which is why you can know, it's not the previous number. If I said n equals 20, what would that mean? It's getting smaller and smaller, but it's stopped just short of getting there. I think it's 0.011 or something like that, okay? So you see how understanding that this is about time, and about how much something is growing, or in this case, getting smaller, okay? That's the key to understand, therefore, n has to be greater than 21. Does that make sense? Because it could be 21, or it could be 22 or 23. Any of those numbers will be fine, because we've gone past the tipping point, if you like. Okay? Okay, so therefore 21 is the actual integer I'm interested in.
So if we didn't ask for integer, we could just say 20.7 and bring it up.
If they didn't ask for an integer, right? So it's a bit tricky because if they said, oh, okay, what specific?
3.64.
Exactly. So it's like, how do I pick one? So what you do is you have to say you just have to provide the whole lot. Blah 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 blah. Right? Because if you say 20.64, I can say, no, I can get one that's smaller than that, but still bigger than this number. And I can play this game forever. Right? So you actually have to leave this, if it was not an integer, you'd have to leave it there. That's what you have to resolve. Okay?